Blendboards presents LED power measurements. We put together this little benchtop setup to demonstrate LED illumination, what's required for voltage and power to keep an LED lit. There's been a lot of debate over the years about what you got to do to make an LED stay lit or be lit, and I think you'll be surprised at how wide of a variety of currents can be used with the LED and still keep the LED lit. In this setup, we're running at 9 volts and we have a variable resistor driving a white LED. We have a voltmeter across the resistor to measure the voltage, which can determine the current into the LED. Our breadboard is powered by a breadboard power supply that provides 5 volts. In our starting condition, we're measuring about 2 volts over 200 ohms, which would be a 10 milliamp drive into the LED. And the LED is well illuminated at this level of drive. Now let's increase the resistance and see what point the LED cuts off at. $300 ohms, 400 ohms, 500 ohms, 600 ohms, 700 ohms, 800 ohms, 900 ohms, 1000 ohms, 2000 ohms, 3000, 4000, 5000, 6000, 7000, 8000, 9000, 10,000 ohms. So here we are at 10K series resistors, and we shut off the lights in the room, and you can see the LED is still illuminated with a 10K series resistor. So let's take a look at the plot of the data that we just took. On the far upper right corner, you see the voltage across the LED was about 3.05 volts, give or take, at the 10 milliamps, down to the bottom lower left corner, where it's a little bit over 2.6 volts at almost no current compared to the top of the range, very low current. And the curve, it's, I guess, kind of a predictable curve in here for a semiconductor device. That does show that there's a wide range of illumination with an LED though. Now whether it's usable at that bottom end of the scale or not is a whole different question, but certainly there is illumination in a wide range up in the top even. This leads to a question: can a chain of LEDs be driven from an unregulated power supply? So what if we took an unregulated 12 volt power supply, like the kind of wall wart you might get, let's say from China, and attached 4 white LEDs across it? What would you expect to see happen? Would the LEDs blow up? Would they even light up? Or would it just all work out in the end? Hey, looking back at our curve, we can see that at 3 volts, which is the nominal voltage you'd see across the LEDs, that works out to about 8 milliamps, which certainly is a safe value for the LED. But will this really work? The question boils down to how unregulated is the 12 volt supply. As you can see, you're at 10 milliamps when you're at 3.05 volts, so how high up would it need to be unregulated to hurt the LED? An unregulated supply is likely to run high in voltage, and 10 milliamps or 20 milliamps, and these are all in series, really isn't a lot of current, so it would typically run high for a normal 1 amp wall wart. So can we fix this problem? Well, it boils down to, can we characterize the highest voltage? Well, let's make an assumption that the highest voltage you would see is 13.5 volts. At that 10 milliamps, to drop the 1.5 volt that you would need to drop, that would be 135 ohms, which is a perfectly reasonable value to find something in that range. So here's the setup with 135 ohm series resistor and 4 white LEDs, and I vary the voltage here from 10 to 14 volts, and the lights stay perfectly finely illuminated. 14. Move the lights out of the way so you get a better view. And you can watch the current drop, or the voltage drop, across the series resistor. When you get down to 10 volts, it's only a few millivolts of voltage drop across that series resistor. There was a scale change in there. The reason being it's down to that low end of the curve that we saw in the other curve. Looks like around 20 millivolts dropped at the 10 volt point. But by the time you get up to 12 volts, it's dropping a significant amount of voltage at 3/4 of a volt almost. At 14 volts, it's dropping about 1.5 volts. This pretty well correlates to the chart that we made earlier. The series resistor would probably also compensate for some variability in parts. Now note red, green, yellow, white LEDs all have different forward voltages from each other. This looks like it'll work fine for the intended purpose, even with an unregulated supply. I want to put lights above my kitchen cabinets to light the counter below it. I don't want a lot of light, and I don't want one that consumes much power. And I don't mind if it's on all the time. It just needs to be okay with an unregulated voltage source. Hopefully this was helpful in dispelling some common myths about LEDs. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of these cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.